Hi there, honors algebra students, or all algebra students. Sorry about that. Today we're going to talk about solving quadratic equations by factoring. All right. Now, I know you know how to solve an equation like this, but this is not a quadratic equation. This is a linear equation, right? Highest power is 1. This is linear. And of course, here you would listen to Saddam, you'd work or reverse order of operations, right? Add 5 to both sides. You get 3x equals 18. And then you would divide by 3, right? And you get x equals 6. All right, that is a linear equation. We're not going to solve quadratic equations like that at all. One method we might use to solve a quadratic equation is factoring. Yeah, we're going to factor. Okay, now before we do, I need to ask you this question. How can you get 0 as a product? Well, in other words, what multiplication problem could equal 0? Well, you might have 5 times 0. That would equal 0, right? Then again, you might have 0 times 7. That would equal 0. How about negative 3 times 0? Yeah, that would equal 0. How about a Google, which is a 1 followed by 100 zeros, uh, times 0? Yeah, that would equal 0. How about How about 0 times Batman? What do you think? 0 times Batman? Yeah, that equals 0 too. The trick for getting 0 as a product is to have one of the factors be 0, right? One of the factors must be 0. Did I say that enough times? Well, Gotham, are you listening? One of the factors must be 0. One of them, not both. They both could be 0, but only one of them has to be 0. Okay, it doesn't matter if it's the first one or the second one. So if one of the factors is 0 and I multiply, I get 0 as an answer, right? Okay, so let me see here. Let's go back to this. We're going to go ahead and factor, and hopefully you're noticing that this is these special patterns by now. This is the difference of perfect squares that was talked about in an earlier video. And hopefully you can just go bam, pow. This is too easy, Mr. Lawrence. You're not challenging me. Okay, now this is how x squared minus 9 factors, right? Okay, now we need one of these quantities to equal 0. One of them, not both. They both could, but one of them. So what we're going to do is we're going to write down x plus 3 equals 0, like a linear equation, and we're going to solve it. Oops. So one of the possible answers for x is negative 3. X could be negative 3. Or we're also going to write down x minus 3 equals 0, and we're going to solve for x. Okay, x is going to equal positive 3. So our actual answer here is that x would equal plus or minus 3. Either one of those will give us a 0 for an answer. Now, please don't think, oh, I just look and I know it's the opposite sign. That won't always be the case. We're going to do somewhere it is and somewhere it isn't. Okay, so let's go on to this one over here. I've got a trinomial. It's not one of my special patterns. I'm going to look here. I need 6 times 1, right? I need 2 factors of 6 that add to get negative 5. Well, looks like a negative 2 and a negative 3, right? So I'm going to go x squared minus 2x minus 3x plus 6 equals 0. I'll do my little grouping thing just like this. Grab that sign, put a plus in between, and I will factor out my common factors. I'll have x times quantity x minus 2, and I'll have a negative 3 times quantity x minus 2. That will equal 0. I'll get x minus 2 times quantity as a quantity times quantity of x minus 3. Now, what do I do here? This is where I set them equal to 0. I go x minus 2 equals 0, and I solve for x. And here I go x minus 3 equals 0, and I solve for x. Okay, so there we go. All right, now again, remember I told you it's not always going to be just the opposite sign of the number. Be careful. Okay, number 3. I'm getting ready to factor, but you know what I notice? I notice 10, 25, and 60. I see a GCF of 5. I'm going to pull a 5 out. I'm going to be left with 2x squared minus 5x minus 12. And it's going to equal 0. I'm going to try to factor that, the 2x squared minus 5x minus 12. That'll be easier. So I've got 2 times negative 12, I got 24. I'm going to need two factors of 24 that subtract to get negative 5. You know what I'm thinking? I'm thinking 3 minus 8. That's right. So I got a 5 out front. I got a 2x squared. I'm going to go with a minus 8x plus 3x minus 12. Why did I write it in that order? Because I simply thought the 2x squared and the 8x went well together, and the 3x and the negative 12 went well together. Gonna do my grouping thing, grab the sign, put a plus in between. Okay, now I'm gonna have 5 times the quantity of, it's like a 2x times the quantity of x minus 4. I'm gonna pull out a 3 times the quantity of x minus 4. I really like the way this is falling apart. So I'm going to have 5. There's my GCF right there. I'm going to pull that out, x minus 4. What's left? A 2x and a positive 3. Now, those of you who are just going, oh, I know the answer is just going to be whatever. No, please set them equal to 0. I'm actually going to take this one and set it equal to 0. Does 5 equal 0? No, it doesn't. I will ignore it. Okay, if there was a way I could turn it into 0, if a variable was in there, I'd have to solve it, but 5 is not going to equal 0. I will ignore that one. I'm going to have x minus 4 equals 0. Well, I'm going to add 4 to each side. I'm going to x equals 4. Mr. Lawrence, you said it wasn't going to always be that way. Well, it's not. Watch this one. I'm going to 2x plus 3 equals 0. And this is where you need to do the technique I'm showing you. Some of you are going to be able to do this in your head. Some of you won't. Some of you think you can do it in your head, but you can't. So don't. All right, 2x is going to equal negative 3. Okay. I'm going to divide by 2. Going to divide by 2. And so x is going to equal negative 3 over 2, or negative 1/2. There are your two answers for x. 4 or negative 3 over 2. Some of you might be wondering, will there always be two answers? No, there doesn't have to be. There can be no solution. There could be one solution, or there could be two, and we'll talk more about that later. All right, let's see here. Let's do this one. I don't see any GCF. I do 12 times 5, and I'm going to get 60. I need two factors of 60 that subtract to get 17. Off the top of my head, I'm thinking 3 and 20, right? 3 minus 20. Okay, so I'm going to have 12x squared plus 3x minus 20x minus 5. That'll equal 0. I'll do my little grouping. I like to do my little grouping thing. Good at it. Okay, I'll GCF the first quantity, pulling out a 3x, being left with a 4x plus 1. I'll pull out a negative 5 from the second quantity, being left with a 4x plus 1. That'll equal 0. I got a GCF one more time. Looks like I got a 4x plus 1 times a 3x minus 5. That'll equal 0. Now this will be a great example of why you can't just, know the answer. It's not like negative 1. Negative 1 will not work. 4x plus 1 equals 0. I will solve for x. Divide by 4. Divide by 4. So x will equal negative 1/4. Okay. Then I have to do 3x minus 5 equal to 0. 3x equals 5. Sorry, I skipped a step there. Hope you don't mind. Divide by 3. X will equal 5/3, or better yet, 1 2/3. So my answers are x could be negative 1/4, or, sorry about that. I hope I stopped that sneeze in time. Hope I didn't blow out your eardrums. Pardon me if I did. And there are your two answers. Okay, two more problems, and then we'll call this video done. Okay, number 5. You know what? I see a perfect square. I see a perfect square. I do. I'm going to move these problems down here. Bring my lines. Okay, I'm going to check. This might be a perfect square trinomial. If it is, I'm going to do the yippee skippy dance. Square root of 16x squared, 4x. Square root of 25, 5. 4 times 5 is 20. Double is 40x. You bet your boots. It's a perfect square trinomial. 4x and a 5. 4x and a 5. I got a plus here. It means that sign shows up twice. Minus, minus. This equals 0. It's supposed to equal 0. I must have not have written it. Now, I'm going to set 4x minus 5 equal to 0. I'm going to solve for x. 4x is going to equal 5, which means that x is going to equal 5/4 or 1 1/4. Am I going to do it again here? No, it'd be a waste of time. This is a situation where there's only one solution. It's the same exact quantity. Of course, I'm going to get the same exact answer. I'm not going to give the same answer twice. Not in this type of problem. Okay, number 6. I see a perfect square. I see a perfect square, and I see division or subtraction. This is a perfect square, difference of perfect squares pattern. This is even easier to factor than the last one. Okay, I know that the square root of 100x squared is 10x. The square root of 1 is 1. This is going to factor as 10x plus 1 times the quantity of 10x minus 1. Am I going to need to solve two equations on this one? I sure will, because 10x plus 1 is not the same as 10x minus 1. So I'm going to go 10x plus 1 equal to 0. 10x minus 1, oops, I'm not sure what's going on there. And that's going to equal 0. I'm going to solve them. Subtract 1, subtract 1. 10x is going to equal -1. Okay, I'm going to divide by 10. Please show this work. A lot of you just like to go, oh, x is 10, and it makes no sense whatsoever. The answer here is x equals -1/10. Okay, over here I'll add 1, add 1. 10x is going to equal 1. I'm going to divide by 10, going to divide by 10. X is going to equal +1/10. Okay, there we go. Pretty easy stuff. All right, you know what? It's 10 after 4 on Friday afternoon, and Mr. Lawrence is tired. I will talk to you later. Good night, everybody.